Okay, I'm going to give you some notes very, very quickly, if you need to take them down. Both loops induce an EMF. Therefore, the total EMF will be as the original formula. Can you identify the formula first of all? Yes, if you identified that it is E equals 2 times BLV sin volt. You should know what the abbreviation stands for by now. Very, very quickly, I'll put the next up note for you now. In the plane WY, that's that vertical plane, the angle is 0. Thus the EMF is 0. There's no angle formed between the conductor loop and the magnetic field in its vertical position, so the EMF will be 0. Obviously, as the conductor loop moves from its vertical position right the way through to XZ, an angle has been formed. Therefore, an EMF has been induced into the conductor. However, once it reaches XZ, its horizontal plane, then it's reached its maximum angle and therefore maximum EMF. Okay everyone, let's move on. One more note on there at the bottom, you can get that down if you wish. However, what I want you to do is take down that drawing and you should be able to identify what type of waveform it is. I'll give you a couple of minutes just to take that diagram. The scale might be a bit hard to read, so I will read it out. On the left hand side of the scale, I'll actually highlight it for you. We'll go from the top to the bottom there, like so. I'll put in some dashes. Like so. We have, on this side, minus, that's 1.0, minus 0.5. We have 0 there, of course. I'll change the colour pen for you. We'll go for green. We have 0.5. Obviously that's going to be a plus. And we've got 1 at the top, like so. So we're going from minus 1 all the way through to plus 1. Similarly, on this scale here, if I highlight that scale very, very quickly for you along the bottom there, like so. Put some dashes in for you. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I'll read the figures out for you on that horizontal scale if you wish. We are going to start from 30, 60, 90, adding 30 on every time, 120, 150, 180, 210, 240, 270, 300 and 330. So start from 30 and end up at 330, adding 30 along the way for each set of numbers. I'll give you a minute to take that down. Okay, you should be able to recognise that it is a AC type waveform, and in the top right hand side of the diagram there you can see the same conductor loop as we've been referring to before, and you can guess what the waveform represents. Alex, if you can inform the group very quickly. If Alex said yes, 1 complete revolution of the conductor loop, yes, Alex is right, but we need a bit more in-depth explanation. I'll give you another 30 seconds to finish that diagram off. Okay, just going to clear my drawings very quickly. We'll clear the ink off it, makes it a bit more clear. And we should be in a position now where more or less we can move on. Everyone ready? Would you like another 30 seconds? I thought you might say that. Okay, I'll give you another 30 seconds. Okay folks, let's crack on. We're going to start with the conductor coil. With which coil? Superb, the conductor coil. Make a note very quickly. We'll start with the conductor coil in its vertical axis. Jonathan, if you can inform the group of the position of the conductor coil, very quickly do so. Excellent. In its vertical position, WY. You can see that in the top diagram there. If I highlight it for you very quickly like so. WY. I'll just correct that very quickly so it makes it a bit more clear for you to see. Like so. Okay, let's move on. I'm just going to shift to the other side of the board very quickly. You can see then from its vertical position the conductor loop is in the plane WY. In its vertical position. Therefore it's got to start from somewhere. We'll say it starts from this point here on the 0 axis. Make a note. It starts from which position? Let's have this time James. Okay, from its 0 position. When the conductor loop is in its vertical position, the plane WY, the induced EMF alley is going to be what value? 0. Well done. So we'll start from that point there. You can see then as the conductor loop on the top right diagram starts to move from the plane WY, an angle is formed before it reaches its horizontal plane XZ. You should have that information down already, therefore we should be able to move on. As the conductor loop starts to rotate through XZ, it reaches its maximum possible angle in terms of cutting through the magnetic field. Therefore, the voltage or the EMF induced into the conductor loop rises to this point here, like so, on your diagrams. You may wish to indicate that right now. I'll give you a couple of seconds to do that. And you can see that it has reached 90 degrees. We can represent that by following this arrow all the way down in this direction to the horizontal axis where it represents 90 degrees. Maximum EMF, or as in the diagram it indicates, EM, meaning electromotive force. EM in the blue circle.